Welcome. I'm Liz Summer from OnLogic, and I'm excited for today's webinar, Edge AI for Intelligent Transportation. We're about to start, but first, hopefully you see a poll, and I'd love to know what might be preventing you or your organization from scaling Edge AI. So please take a moment and choose the most relevant answer. Maybe you have budget or ROI concerns. Maybe it's hardware reliability, Build America, Buy America compliance, or remote device management, or maybe you have data privacy concerns. So please take a moment and cast your answer, and I'll share the results soon. This is great. I see some answers coming in. Thank you for casting your answers. We'll take a few moments here, allow others to cast some answers. Okay, I'm going to close the poll here soon and share the answers. All right. I'm going to go ahead and end the poll. Thank you for casting your answers. All righty. Okay, so I'll share the results. So it looks like the majority of people really have some budget or ROI concerns, and I think that's really the majority of any large project's concern is budget. But we also see next up is that remote device management, and we'll talk about that in today's webinars. So look forward to hearing more about that. We also have security and data privacy concerns, BABA compliance, which we'll hear more about, and hardware reliability. So the good news is you will hear more about that during today's webinar. So before we move into the webinar, let's take care of a few housekeeping items. Please use the Zoom Q&A section located at the bottom of your screen to type in any questions you have during the webinar. We welcome questions at any time, but we will dedicate a specific session at the end of the webinar to answer your questions. This session is being recorded and will be available to attendees on OnLogic's YouTube channel. All attendees will receive an email after the webinar with a link to the recording. By default, attendees will receive attendee audio and video are muted and disabled. With our housekeeping items out of the way, I'm excited to introduce the host of today's webinar, Adam Hill, editor at ITS International. Adam, without further ado, take it away.
Thanks very much indeed, Liz. Hello, good morning, good afternoon, good evening, wherever you are in the world, and welcome. I'm Adam Hill, editor of ITS International, and I'm delighted to be moderating this webinar, Edge AI for Intelligent Transportation with OnLogic and Intel. The ITS world is always evolving, but things at the roadside have never moved so fast. Drivers for this extraordinary pace of change include improved technology, increased connectivity, but artificial intelligence is adding many more potential layers of opportunity, complexity, and speed. It's one thing to know that, it's quite another to make it work for you. And the path that leads from having a good idea to setting up a pilot project, that's often a relatively short one. But what about turning that pilot into something that will scale up and give you a significant return on investment across a city or a region? Doing something at one intersection is great, but what about 300 intersections? How do you handle workloads at the edge? How do you future-proof what you're doing? And where does AI come in to all of it? Help is at hand. We have two distinguished, experienced speakers who will help us unpick this topic and offer some practical advice. They know this subject forwards, backwards, and sideways. Over the next 45 minutes or so, we're going to be looking at how to choose the right hardware, how you make sure that it's reliable in action. And we'll also be looking at a real world intersection monitoring solution. Let's kick this off. I promised you a couple of distinguished guests, so let me introduce them. Sheldon Sun is VP of Product Engineering at OnLogic, leading the strategy and execution of rugged IoT edge hardware. A tech veteran, he's held engineering leadership roles at Vera Mobility, Intel, and Tektronix. Sheldon specializes in translating complex computing into deployable, scalable hardware strategies. He joins today's webinar to demonstrate how right-sizing hardware unlocks positive ROI for intelligent transportation AI. Welcome, Sheldon.
Thank you, Adam. I'm really excited to join the conversation today.
And you recognized yourself from that description.
I did.
Anthony Abuta is an Intel technologist leading the global transportation business for edge computing. Tony's work centers on applying AI, edge computing for 5G and IoT to modernize real-world transportation infrastructure at scale. He collaborates directly with OEMs, ODMs, system integrators, ISVs, and cities and DOTs to co-design and deploy reliable AI-powered infrastructure across roads, fleets, EV charging networks, rail, ports, and airports. With over 25 years of experience in engineering, product, and business leadership, Tony is a trusted industry speaker and advisor known for bridging deep technology with real-world execution to deliver safer, more efficient, more resilient transportation systems globally. Welcome, Tony.
Thank you so much. A pleasure to be here.
So the goal of today's webinar is to get beyond the frustration of pilot purgatory. This is where you've invested significant budget into pilots for new technologies, but you can't scale them to full execution. You're not seeing the benefits. So first question, and it's to both of you. From your perspectives at Intel and OnLogic, what is the single biggest hurdle preventing DOTs from moving a successful pilot into a full-scale, city-wide deployment? Sheldon, let's hear from you first, and then we'll hear from Tony.
Yeah, there's actually three basic traps that usually companies fall into, right? The first one is the perfect pilot. Obviously, when you're running a pilot, you're in an environment where everything's perfect, right? Your cameras are tuned perfectly. The intersections are, aligned perfectly. There's no construction. These are things that we normally would want to showcase in a pilot because you want that perfect environment. You get the perfect data. You can hand tune all the algorithms in that specific scenario, right? The second trap that people fall into is let's replace all the cameras. And that's, you're changing a lot of variables at the same time. I think the goal here is to reuse as much and change as little variable as you can to just get that repeatability and that ruggedness from what's already existing, right? And also kind of plays into that ROI perspective as well. The third one is the hardware trap, and this is where you look at a system in the field that may be a little bit non-optimal, and that may mean a lot of dust, it may mean a lot of heat, and a system normally needs to breathe. And because of that, if you run into a system that has a fan or doesn't have the adequate cooling, you run into a really messy environment where you have hardware failures because of where you are. So those are the main traps that deployments often fail at. So in order to actually survive this mass deployment initiative, you'll need a rugged system. You'll need a lot of headway in terms of environmentals. That would be thermals, and also allowing your system to actually breathe while it's actually working.
Thanks for that. Tony, give me a hurdle or two.
Yeah, hey, Sheldon has hit the nail on the head. A lot of what he's touched on are things that we experience. At the moment, we're working on some pilots, and I can tell you some of the challenges that we face while scaling these pilots were captured in the poll that we had initially, right? We've worked with research institutions, DOTs, where these pilots really proved amazing when they're put in a bubble, right? We had near miss detections that worked really awesome. We had digital twins, we had real-time analytics, um, you know, but then they didn't scale. And that's always been a frustration. It's like you're just spinning your wheels and you really don't understand how these will scale up. And it's not that technology failed, it's because no one had answered the real question, which is who's funding this 300 devices that's going to scale out, throughout the city. Pilots, they often run on innovation grants. A lot of them that we've worked on, there's grants that that are funding these pilots, and those scaling capabilities, they require something called the capital budget. Procurement needs to be aligned. You have to have the IT security reviews, and then you have to have that clear operational ownership. And today there's also another layer, there's things that, we hear on the news. It's public perception, especially as you're deploying AI and all these cameras out in the field, right? There's a real pushback around cameras and AI. Sometimes it's misinformation, sometimes it's privacy concerns, and sometimes it's just political, right? If leadership is not prepared to explain what the system actually does, right, and doesn't, want to understand how we can stall the deployment or, scale the deployment, it boils down to it's not a technical issue that's a problem scaling this. We have to make sure that the institution is ready for the deployment. We have that funding, we have that ownership, and then also we have that PR, that public communication, so that the public knows when we're installing these AI systems, in the cabinets by the traffic intersections, that these things are there to help them to save lives and also to improve traffic flow. We really need to have that stakeholder alignment. So if a pilot is not really engineered for that reality from day one, it just becomes a really impressive science project, right? What I recommend is, we need to design those pilots like it's already in next year's capital plan. That's how you escape that pilot purgatory, in my opinion.
Is there a sense then in which a pilot, and I think you've alluded to it with your mention of impressive science projects, they're quite exciting to do. The hard work kind of comes later. Is that something of an issue as well, do you think?
I mean, a lot of times when we do these pilots, for example, we're doing a few of them with Curiosity Lab and UT, right? We always try to dimension it in a way that the technology works. Right now we have new chips, new software, new AI models. So we try to optimize them to make sure that that those models are working, the new agentic features that we look at are working in the lab. But sometimes we're too much focused on the technology, right? We don't look beyond scalability, right? And when you're looking at scalability, you're looking at putting these systems and the technology in really remote areas, in these cabinets that are deployed in environments, as Sheldon said, that you're kind of limited by the power budget, and when we're doing these experiments or these this per se science projects, we have the optimal conditions, right? And sometimes what I advise is if we can take these pilots and do them in the actual intersection, right? And do them throughout the year so that you're doing it in spring, in summer, because the main challenge over here is those environmental swings, right? And you really want to deploy, a pilot or a system that can handle the high temperature that's within those cabinets.
We've touched on the technology. There's obviously a performance versus cost equation to reckon with when you're setting anything up. Tony, I'm thinking of the Intel Core Ultra brings a lot of specialized compute to the table.
Yeah.
But for an ITS engineer, how does that architecture change the math when you're trying to balance high intensity AI workloads with strict power and budget, and budget constraints?
Yeah, I mean, that's a great question. And let me just frame this in practical terms. Not too many people understand what Intel Core Ultra is, and what Intel brings to the table in terms of the broad range of processors. To be honest, we have an array, a huge family of processors, all the way from the first generation, 10th, 12th generation. So there's a lot of variations over there. So to frame it from a 30,000-foot level, right, we have a really broad range of processors. We have the very low power chips, to full data center parts. So the Core Ultra sits right in that infrastructure sweet spot, right? It's designed for real deployments and not just the lab demos. So here's the shift. Historically, when you look at an ITS engineer who wanted serious AI at intersections, maybe multi-camera detections, pedestrian analytics, the answer was simple. You really need to add more compute at that point. Often that means you're adding a separate graphic processing unit, a GPU, and essentially it's another processor that's dedicated to heavy visual workloads. You guys have had GPUs; those are the big, processors that are used to train AI algorithms. Most of those are usually in data centers, and they're very power hungry. But you'd push these systems into a much higher power range if you're deploying those GPUs in your small cabinet. And that's where reality kicks in. I mean, to be honest, I've been in the field and, I've opened those roadside cabinets in Texas in the summer, and those things are really hot, and as I said before, these things are like glorified pizza ovens. They're really, really hot. So you want to make sure that you can have a system over there that can really handle that power swings, especially, with what's going on in the climate. You have very cold winters and then you have very hot summers. And within those cabinets, you really don't have fans, right? So the cabinets that I'm talking about, they're not data centers. And if you're driving around on the intersections, you'll see those metal boxes sitting on the side of the road. That's where we put all our systems and edge AI compute. So once you factor in things like the system controllers, the radios, and other systems over here, realistically, you're working with a limited power headroom, right? Limited space. So that old equation, as you're talking about the math, it kind of looked at like you have more AI performance equals more power. So as a city scales, that really becomes very expensive, right? You're not just looking at more power in terms of electricity, cooling, and just long-term maintenance. Core Ultra changes that equation, because the architecture kind of shifted, right? It's fundamentally different from what we had before. Instead of one main CPU like we had in the previous generation, doing everything, because you had one CPU and then you added a GPU in there. You have multiple specialized engine built on a single compute. So you have the CPU, the integrated GPU, and the NPU. And I can just go a little bit into what those means. So your GPU has these cores, right, that do heavy logic, and then within those cores, you have the performance cores, you have the efficiency cores, and then you have also the low power efficiency cores. I would love to go into the rat hole, digging into these processor terminology and how that goes, but I think we'll leave that for another day. But what we're talking about here is now we have an integrated, dedicated NPU, neural processing unit, in this Core Ultra, and that's optimized for always on, AI at a very low power. So instead of scaling performance by adding more hardware and more heat, you scale performance by dividing the work intelligently. So now you can do things like vehicle detection runs on the NPU, you have video processing that runs on the GPU, and then you have signal logic and networking, those stays on the CPU. So now the equation, as we're talking about how Core Ultra changes the math, you have more AI at the cabinet, which equals without more power, if you're thinking about how we did it in the old school. And that's what makes this more deployable and more scalable.
Tony, thanks for that.
Yeah.
Sheldon, let's talk about right sizing then, because I think there's a temptation to overspec for the future or underspec to save money. So how should project managers be looking at evaluating a system to ensure that it handles what you need today in terms of intersection monitoring, but it's not going to be obsolete in 3 years' time?
Yeah, that's a really difficult thing to do, but when Tony described Arrow Lake, it became very easy to kind of put a story together around like how does that solution help, right? So if you look at the way that, like Tony mentioned, you're in a system, you're in the edge of the cabinet, it's hot. You don't want to be over or under specing a system where you're loading a massive amount of AI modules or algorithms to overload a system, because not only are you running hot, you're running at 100% capacity of that processor that you're using, which kind of affects the failure rate of your system. If you're running that at 100% on 24 hours, 7 days a week, you are going to have failures and multiple failures, right? On the other side, if you actually go and overspec and you're only running 10% of it, you're still running hot, and you're not utilizing, the core architecture of Arrow Lake. Bring in Tony and his little blurb on Arrow Lake, where you have the CPU, you have the GPU, you have the NPU. Now, as an OnLogic, manufacturer of rugged computers, this is like a dream for us, because now not only do you scale and use, the benefits of Intel and NPU, GPU, and CPU. Now you marry that with our rugged thermal solution, and our system. Now you actually have that thermal headroom to be in that cabinet at 40, 50 degrees Celsius, right? And, the nice thing is, because at lighter workloads, you're going to be using the NPU. You're saving your system from not running it at 100%. As the use case comes up, maybe 2 years or 3 years down the road, you're loading on those new use cases remotely, and now you're allowed to scale that way. So, right sizing doesn't mean, let's go buy something that we need 10 years from now that you don't know that you're going to use. Right sizing means let's get something that we know that we can use and that will scale with us, not only from, a technology perspective, but also an environmental perspective, and also a longevity perspective, because, having those three key components in a single processing unit is tremendous. It's a game changer for this type of industry.
Thanks for that. Let's dive a bit more into this issue of performance and reliability. You've both been very, very vivid, which is fantastic. Tony, I love the idea of a traffic cabinet as a pizza oven. That's, that I don't think anything puts it across better than that. These are the environments that this equipment is going to be working in. So, Sheldon, roadside enclosures are notoriously dirty environments, as we've seen: high heat, vibration, limited airflow. So why is a purpose-built industrial system a necessity here rather than a nice to have? There's
Right.
commercial grade hardware out there. So
Yeah, if you look at a commercial grade, hardware, most of those commercial grade hardwares come with a fan, right? Because you have a clean environment, you're inside, you're in a semi-controlled environment where, your compute can work. You're sucking in air, you're cooling your processors, you may have some liquid cooling and so on, in a more advanced commercial hardware. You can't translate that to, let's put it in the pizza oven, right? I mean, like Tony said, that cabinet is hot. Not only is it hot, it's not completely sealed. So you may have environments where the dust is blowing through. You may have brake dust flying through. You may have humidity. You may have a lot of big, the four seasons, like Tony mentioned. You're not only looking at the summer, you're looking at extreme cold on the other hand too. You want a system that just doesn't breathe, right? If you breathe, you're going to suck in the dust, you're going to suck in the particulates, you're just going to kind of corrupt that system. Having a rugged system that's fanless at the edge is a huge benefit for this type of application.
thank you for that. Maintenance is a massive part of OpEx. So where does remote device management come in to reduce, say, truck rolls? This is where we're sending a technician to a site. It's costly in terms of time, money, labor, all the rest of it. And also then, what does that mean for the long-term ROI of an ITS project if we can get that right? Sheldon, let's come to you on that.
Yeah, if you're climbing up on a pole, or rolling a truck all the time, it's not really a good place to be. And quite honestly, 80% of issues that can be actually resolved by just turning off and on the system. So if you just take a look at that alone, having remote access like a BMC, which is also a baseboard management controller, which is an out-of-band network controller, you can basically go in the system, reset it, and right from the remote application or your control center, like somewhere else. You don't need to roll a truck. That's going to save you thousands of dollars. It even gets more expensive, even if you have to roll a truck and stop traffic. So I think having that remote management is a tremendous benefit of a compute system, especially, if you have that BMC built right into it. Not only does it allow you to do remote control off and on, if you need security patches, if a hacker comes in, finds a way to infiltrate a network, security features and patches may need to be provided or installed from a firmware level or a BIOS level. A BMC allows you to do that as well. So not only are you safeguarding it from the, just an on-off, but you're actually safeguarding it from future attacks.
Tony, give me your thoughts on the importance of remote management as opposed to getting out there and getting dirty.
Yeah, hey, Sheldon described the physical reality perfectly, right? Let me build on that from an operational side. When you're managing, let's say, 5 intersections, that truck roll is annoying. But when you're managing 300, a whole citywide, it's a big line item on your budget. That's where remote management becomes critical, right? Sheldon mentioned BMC, the baseball management controller. That's essentially that small dedicated management processor built into the hardware, that allows you to have that, secure hardware level access to the system. Even when the main operating system crashes. We've had our laptops that have those blue screens, right? So imagine you have those blue screens on 200 devices out there, sending all those truckloads out there and closing the lanes. That's a nightmare, right? On top of what Sheldon mentioned, Intel platforms, they come with technology like Intel vPro, Intel Active Management Technology, which is AMT, which provide out-of-band management. That simply means that you can securely access and control that device even when that OS is frozen or crashed. So instead of dispatching that technician out there, right, you're now able to do that remote power cycling the device. You can access the BIOS level settings. You can push those firmware updates out there. And then also you can monitor the hardware telemetry like CPU temperature and voltage. From a central operational center, industry data shows that, the percentage of system issues that can be resolved with a simple reboot is high, right? If a reboot is remote instead of a $2,000, $3,000, truck roll and lane closure, that, add that up, that math kind of changes pretty quickly, right? And this goes beyond assets. We have secure over-the-air updates where you can deploy new AI models, right? Apply security patches, and you're talking about critical infrastructure. So you really don't want anybody to be accessing those systems and messing around with the traffic lights. That's endangering people's safety. And then that kind of moves you from reactive maintenance when something crashes up on the remote area of your city to predictive fleet management. You want to be able to manage 300 intersections from a central location. So that rugged hardware that OnLogic has and others, it keeps that system alive. You're not ingesting all that dust. You're within the thermal limits, and remote manageability that keeps your program financially alive. And at a city scale, that's what protects your long-term ROI. You're looking at ROI when you're deploying these systems across your cities.
Thank you both very much for that. We're going to have a slight change of pace, and I will say thank you to attendees who've put in questions already. Really appreciate that. And we will come to them, I promise. And if you have questions, please put them in. We will answer them towards the end, but get them in and we can get to them. Okay. We've had a great discussion about right-sizing hardware, processing power, system maintenance, ROI. Let's now explore a joint Intel OnLogic solution. This is a real-world example of how transportation infrastructure can become aware, connected, responsive to its environment. Tony, we're going to play a demo. Could you just give us some context? And you're going to be commentating on it. Thank you.
Yeah.
But could you just give us some context as to what we'll be seeing in the video?
Yeah, absolutely, Adam. What you're about to see is a demo that we did with RTS World Congress. It uses real video feeds from an intersection, live from Arizona. We have 4 standard IP cameras, no special hardware on the pole, right? We didn't make the camera smart in this demo. We made that intersection, we call it super smart, and you'll see how that goes. So all the intelligence in this demo, it runs on the edge on a rugged OnLogic hardware powered by Intel, using Scenescape, which is an open edge platform. You guys can go on intel.com and download it. Scenescape, what it does, it fuses all those feeds from all those cameras, into a spatially aware digital twin. So you'll kind of see the digital twin of this intersection, and it adds reasoning. We have scene intelligent, and then we have agentic AI on this demo. You will see how a traffic engineer, and this is on the lens of a traffic engineer, how they can define regions of interest, track objects across 2D, 3D, and then turn that raw video into structured data flowing into open dashboards like Grafana. So this demo, what it does, it shows you how to go from a video to understanding to intelligent decisions. So yeah, let's take a look when you're ready. So, all right, this is Scenescape. This is a scenes view, the digital twin, 4 cameras, 16 regions of interest configured. This is where video becomes the context. On the next screen, we're in the 2D view. You'll see those blue dots you see moving. Those are tracked objects. Those are vehicles and pedestrians being continuously tracked across camera feeds. The red outlines, those are predefined regions of interest, the lanes, approaches, the intersection box itself. This is persistent multi-camera tracking. This is not just detecting one frame. You'll see you can toggle between the live view, the telemetry, the visualize ROIs. This is powerful because engineers can dynamically turn on analytics layer without writing code. And below you'll see 4 live cameras all feeding into this unified model. Camera, sensors, region, tripwires, MQTT, everything in modular and configurable view. This is a 3D view, and this is where it gets interesting. You're no longer looking at a flat video, you're looking at volumetric digital twins. And you can see all the blue objects tracking. Those are live tracked, vehicles represented in 3D space. Those are not just pixel detections. Those are spatially positioned objects inside the intersection. This allows you to understand proximity, trajectory, and potential conflicts of interest. Over there, you're seeing the toggling of regions of interest. You can color code lanes different from the central intersection box. You have volumetric heights, buffer sizes. Everything is adjustable, no code required. This is where engineering meets policy. You define what matters, left turns, pedestrian zones, you have queue length areas, and the system measures it. And here you see volumetric, green cubes and, adjustments of how you want to view. And you can see the green cubes over there. Those are pedestrians on the crosswalk, fully tracked in 3D. This is not just person detected. This is spatially contextualized pedestrian presence inside a defined safety zone. And when you look closely, you'll see yellow icons that are camera positions. What Scenescape does, it automatically calibrates camera placement inside the digital twin, matching azimuths, heights, and angles, to be detected objects and scene geometry. This alignment is critical for accurate cross camera tracking. Also over here, you're looking at the live view. You can see bounding boxes in the camera feeds below, live inferencing running at about 15 frames per second. Here you're looking at Node-RED. This is where you move from visualization to orchestration, right? Scenescape is publishing structural events over MQTT. We subscribe to region-level object activities. No video leaving the intersection, just clean JSON events. These function nodes processes the payload, extracting region, object type, dwell time, and here we send it to InfluxDB, a time series database. Now those movements become queryable analytics, dashboards, alerts, historical trends. Here you're looking at Grafana, an open source, widely adopted. This is the operational dashboard layer. You can see no alerts for jaywalking, meaning the crosswalk is behaving normally. You can see VRU map, vulnerable road users shown in green. That's live pedestrian positioning derived from the edge events, not video. This is structural telemetry. And then you have other metrics that you can see as well. Here we're looking at the traffic monitoring tab. Now we move from analytics to operational intelligence. This is where the traffic monitoring system interfaces, powered by the same edge intelligence. You can see the live camera feeds. To the right, you can see the traffic summary by direction. Below that, you can see the environmental data, from a weather API. At the bottom, you see the traffic status and alerts. So here you can see bounding boxes updating live. You can also see the info alerts to critical alerts. This is not because someone is hard-coded a rule. It's because the system understands congestion platforms and patterns in context. That's where reasoning comes in. And you can toggle between cameras to see traffic summaries updating in real time. There's no guessing here. It's no manual counting. This is all synchronized, edge-generated telemetry. Now you can also look at the environmental data over there, wind, humidity. What does all this matter? Because, traffic behavior changes with weather, and the system can factor that into reasoning. That's what we call scene intelligent layered with context. And here's what's important about this, those traffic status and alerts, you can see critical alerts, you can see recommendation analysis. This is agentic AI. The system is not just detecting, it's interpreting, it's summarizing, it's recommending. For example, if you have drivers on the west direction, there's a lot that this system can do. And this is what we call the art of the possible.
Tony, thanks for that. I can't be the only one who gets a kick out of seeing that sort of real world activity. It's extraordinary stuff. Edge AI, we know, is going to be just something that will be bigger and bigger and bigger in smart transportation. It's only going to grow. Can we dig a little deeper into what that means in practice? Tony, for example, we've seen the smart camera approach where each unit can cost you $20,000. How does your architecture, the two of you, allow a city to achieve the same or better results using the infrastructure that they've got in place already?
I've seen those smart cameras. They look beautiful. I can't complain about that. But if you look at the smart camera model, they put compute into every pole. That's what the smart camera model. So every upgrade, every new capability means buying another 15 to 20K device. And you've looked at that demo that we did. You have to have cameras aligned with the lanes, and for an intersection, you may need 4 cameras, right? And do that math. 80K in one intersection, multiply that by 300. The math doesn't math. One camera works for a pilot, but at a city scale, it gets expensive really fast. And one key thing about working with DOTs and cities, they're budget constrained, right? So what we're doing with OnLogic is different. We're separating the sensors from the intelligence. Cities keep your IP cameras up there, and then we're bringing in the centralized AI at the edge, on a rugged device that can process multiple feeds at once. So instead of buying intelligence 4 times at one intersection, you deploy one edge system in a box, you feed all those cameras into it, and that kind of lowers your total cost of ownership, But more importantly, it gives you flexibility. If you want new models, pedestrian V2X. You can update software. You don't replace the hardware on a pole. And because it's open, you're not really, locked into proprietary stack as these smart cameras are. So instead of buying more smarter cameras, we make the entire intersection super smart in a way that it actually scales with, edge computing.
And one thing we haven't mentioned actually is Build America, Buy America, the BABA requirements for agencies who want federal funding. They need to have BABA compliant partners. OnLogic has a US-based assembly and in-region support. How does that help overcome regulatory hurdles? Sheldon.
Yeah, thanks for bringing that up. We actually do have our own manufacturing here in Vermont, and we see a strategic advantage of doing that. And it comes down to three main things, right? So speed, right? So the BABA Act requires U.S. assembled systems especially for federally funded projects. And, OnLogic being in the U.S., having our manufacturing plant here, it's a huge advantage to our system integrators, right? So you don't have to worry about filling in that extra paperwork because you're pulling in something from a foreign country. You can check that box and go straight to the buying counter because we're manufacturing that here. Secondly is security. Because we build it here, you can trust that it's coming from a trusted U.S. source, right? And third is, again, we are here. So I guess the theme is we are here, and we are here. From a support perspective, later on when you need upgrades or you want to redeploy new things in different intersections, it's a quick phone call to our office in the US and we can have that same system sent back out to you so you can redeploy. So, I think all three of those things are really important as you look for a partner to solve your solution at your smart city infrastructure.
Well, just before we move to Q&A, this is no time for modesty. You've both got a chance to tell us about your products. So Intel Arrow Lake, OnLogic has its own products. Tony, let's start with you. Sheldon, will come to you. Give us a few lines on why you guys.
Well, I mean, we have products that are scalable, that are open, and you've seen how the demos and how we can scale from a small pilot and scale up. We have that technology that can enable DOTs and transportation engineers to take existing infrastructure, existing cameras into these systems that are foundational to systems that OnLogic builds and scale them up, update models over the air, provide security on the edge. And we're just getting started with even the next technology, the next generation of these systems. And of course, we have these systems that are long life cycle and they can have that extended temperature and survive in those rugged environments that the edge compute and the traffic intersections provide or need.
Thank you. Sheldon, over to you.
Yeah, in addition to the hardware, the brains part of it, I think if you look at OnLogic, we provide the body, and it's not all about the cameras that are out there, like Tony said. A specific instance may need 4 or 5 or maybe more cameras. Putting out a integrated solution is going to be very, very costly. But having the brains and the body within that cabinet that can support that horsepower that's actually there in terms of thermal headroom and the throttling between the different various compute components, like Tony mentioned, just to kind of summarize the NPU, the GPU, and the CPU, it's really important that we have that thermal headroom. And by having an OnLogic rugged system in there, you have that body that can take that abuse, the environmental abuse, right? So I think those are two things, but I do also want to mention, I think Tony alluded to this before, but we will as well, is that remote kill switch, right? If something goes bad, you get that blue screen, you want to do that update because of security patches. You can remotely turn off and on the system and kind of like keep moving, keep your process moving. Don't need to roll out trucks. Just sit back in your control center and update everything from there. And I think those are the key benefits that we bring to the game.
Thank you for that. We've got a load of questions coming in, which is fantastic because we've got two experts right here. Let's move to Q&A. We've got a good 10 minutes to go through this. So we'll hopefully be able to give plenty of time to what we've got coming up. I'm going to throw them out if that's okay. And guys, if you can decide which of you, just chime in when you want to, who would be the most obvious to answer? Okay, first one, from an anonymous attendee, can you provide examples of any deployments currently in operation? That's a great question, actually.
I can say that AI at intersection is already in multiple cities being deployed, right? I mean, there's some that are ongoing, I can't mention, but I mean, we do have in Atlanta, in Austin, they include adaptive signal optimization, near miss, and pedestrian conflict detection. So yes, we do have a bunch of deployments that are ongoing with Edge AI, and we can get into details after the call on that. Yes.
Thank you. Okay, here's another question from an attendee. AI models are constantly evolving. How do the hardware choices we discussed today, like utilizing the NPU, allow for over-the-air model updates as traffic monitoring needs change? Who would like that one?
I mean, I can go with that. So when you have, your CPU, GPU, and NPU on the same platform, you're not locked into one acceleration path. As models evolve, which we've seen probably about 6 to 12 months, and maybe they get smaller and more efficient, you can retarget them to the best engine without changing the hardware. So with like the NPU with Core Ultra, which is optimized for low power, that means you can deploy updated models of the air. You're not maxing out on GPU or CPU. You're refactoring all those processes on different engines, so you have headroom that can allow you to update. So in the intersection, you really don't need new hardware every time the AI improves. You just update the model, and the silicon stays. That's how you kind of future-proof your deployments.
Thank you. Quite a specific question for Sheldon here. What is the extended temperature range that the OnLogic device can operate at?
So OnLogic offers a couple different variants of our components or our systems, right? So we have the industrial model, right? So that goes from 0 to 50 degrees. So somewhat controlled environment, that system will be good for there. I think if we're talking about this specific application, we also have a rugged product line, and those go from minus 40 degrees C to about 70 degrees C in those hot pizza oven type applications that Tony kind of alluded to at the beginning of this presentation.
Okay, here's another one. How significantly does 5G reduce latency compared to 4G in transferring processed edge data to central management systems? Who fancies that one?
I like that question.
I do too. I like that.
How would I start and then you go after Tony? So I love that question. And the reason is in my previous world, we used to send a lot of data back from the edge all the way back to the data center. And that's very costly. I think with the advancement of edge AI right now, we've tremendously cut down that data. It really doesn't matter. This is insignificant right now. Maybe when we were sending gobs and gobs of data back to the data center, it made a big difference. Right now, with the compute and all that, all the algorithms running on the edge, it's negligible right now. And Tony, I'll turn that over to you to kind of add on that.
Well, I mean, what we've seen is, 5G can reduce latency about 30 to 50 milliseconds, on 4G down to about sub 10 milliseconds. But, here's the key, right? In this architecture that we're talking with OnLogic and Intel on the edge, inference is happening at the edge, right? So latency to the cloud isn't mission critical, right, for detection. So 5G kind of helps with that faster backhaul, higher bandwidth and more reliability uplink structure. But the intersection does not stop thinking if the network slows down. So you're just sending metadata out there. You really don't need that huge bandwidth that 5G provides with this architecture of edge AI.
Thank you for that. Here is another one. What AI algorithms are best suited for real-time video analytics, such as vehicle classification, pedestrian detection, while running on limited power edge hardware?
I can go with that. We're actually doing some pilots, and optimized object detection models, there's YOLO V8, V5, those YOLO variants, and then the MobileNet-based classifiers and quantized neural networks, those work very well. Yeah, but so when you pair those with tools like OpenVINO that kind of orchestrates, what goes to what CPU engine, GPU, and NPU, you know, those models can be very optimized for the Intel CPU, GPU, and NPU acceleration, balancing performance and power efficiency. So the key isn't the model, it's how efficiently it's deployed across those engines at the edge.
Thank you for that. Here is another one. We're just starting out. Our DOT has an existing network of non-AI IP cameras. What is the first technical step to AI enabling that intersection without a total rip and replace?
I can start with that again, Tony. I know that
Okay.
you have a lot more software suite experience here, but realistically, when I was kind of mapping out the intersection, for instance, it would be good to get live data feeds for that before we pick what solution we want to actually implement. So number one, get the live data feeds, feed that through the models. I'm sure Tony has a lot of simulation and algorithms that they can run offline before we choose the right solution. Once we do that, we can implement it in the right package and the right solution, and then work with OnLogic to deploy the correct solution for that application that gives you enough headroom for various algorithms, but also future proofing your algorithms as well.
Yeah, I mean, I'll piggyback on what Sheldon said. You've seen the demos that we've done, right? Keep your cameras, right? Feed all those streams onto an edge compute, and let the magic be done with all the software stack that we have, and the amazing technology that we have with the Core Ultras and the likes, and the ruggedized boxes that OnLogic and team brings to the game.
Here's another one. A ruggedized platform in the field is ideal, but what are ways to help other vendors migrate their application software to this platform, since they may want to use their own proprietary platforms? That's a really nice question, actually.
Yeah. From an OnLogic perspective, we have applications engineers that are willing and ready to help, and system integrators as well, partners that are willing and ready to help you migrate your systems or your proprietary software onto our platforms. And we work very, very closely with Tony and his team to make sure that we're all successful in that implementation.
Thank you for that. Here's
Yeah.
one. What's the return on investment timeline for deploying edge AI for traffic management compared to traditional cloud-based solutions?
So most ROIs come from operational efficiency, right? You've seen about truck rolls, right? So, fewer truck rolls due to remote management, that's one really big saving that you're going to get. You have that lower cloud bandwidth. We're kind of doing a project right now that, we're shipping all our stuff over to the cloud. That's a lot of money, right? You're not ripping and replacing when models evolve. So at scale, those savings compound, quickly, right? So it's not just about safety improvements. It's about reducing ongoing OpEx while improving insights. So yeah, I mean, 12 to 24 months, you can get back your money back.
Okay. Final question, because I want to get to you two. You're each going to give me a pro tip for starting, which we'll do in a minute. Last question from the audience. Does the solution that we've seen today support virtual BSM data creation for use in a V2X environment? Who fancies that one?
What was the question? Sorry, I kind of
the solution that we've seen today, does that support virtual BSM data creation for use in a V2X environment?
The answer is yes. We've done that in pilots, right, where we integrate with RSUs and OBUs for V2X. Yes.
Good stuff. Yes is a great answer. Thank you very much indeed. We've got 5 or so minutes to go. So let's have a look at some of our takeaways from today. I think one of the key words, choose wisely. Ensure you've got enough headroom for what you need to do. Look at your existing infrastructure. Better doesn't necessarily mean new. Simplicity and planning, they will all help ROI. And BABA compliance gives you security, support, and speed. We can argue endlessly over who is the brains and who is the body. Really, really interesting to hear it expressed like that. It's very, again, very vivid, which is incredibly useful when we're trying to understand what are at times quite complicated concepts. Thank you both very much indeed for that. As I say, I'm going to come to you in a second. I've got a note which is to everyone. The first one is thank you so much for your enthusiasm and for taking the time out to be here and for asking a lot of great questions. You will receive an email with a link to an on-demand recording of today's webinar. There'll be more information about smart transportation and there'll be contact information there as well. We'll try to get to any answers that we didn't get to today. Okay, Tony first, give me your one pro tip for starting out. How do you scale up? We've got just give me a minute on that.
Okay, hey, if I leave you with just one thing, it's this. When you're piloting, don't pilot for innovation. Pilot for operations, right? Design your first intersection as if you're deploying 300, right? If the power envelope doesn't scale, if remote management isn't built in, if economics don't hold at city level, it's not a pilot, it's a science project. Just think production from day one, and scaling will become just a replication, rinse and repeat, and not reinvention. And we can help with that, by the way.
You make it sound quite easy.
Well, if you've done it for a long time and you've been spinning that wheel, you kind of come up with a way of finding ways of optimizing it. Yes.
Very good. Sheldon, how about you? Let's have one pro tip from you, please.
So, I didn't realize we used the word brain and body in the compute, but I think the next favorite word of the day for me is scalability, and Tony hit it right on the head. In order to scale, you need to have that thermal headroom, right? And in order to have that thermal headroom, you need to have a really ruggedized system, but not only a ruggedized system that can fit in a pizza oven, but can actually think and be scalable in terms of how do I scale for the future as opposed to how do I scale in massive deployment. And I think, Intel provides that opportunity to scale for the future in terms of compute needs, but to scale in an environment, I think OnLogic, I know OnLogic can provide you an ultimate solution for that as well.
Thank you both very much for that. I didn't expect to hear anything about pizza ovens in today's webinar, so that's always good. Let's now ensure that all our pilots are not impressive science projects. They are scalable, exciting, and above all, profitable ventures. Okay, it just remains for me to say thank you very much to our speakers, Sheldon Sun from OnLogic. Thank you.
Thank you.
Tony from Intel.
Thank you.
And most importantly, thank you all for listening in. We really appreciate it. We know you're busy. It's much appreciated, and I hope you have learned something along the way. So wherever you are in the world, good morning, good afternoon, good evening, and goodbye.